Welcome to the deep dive.
Okay, take a second and just picture a map of Earth. What really stands out? Maybe it's those jagged mountain ranges or the way rivers snake across the land, the huge flat plains or those deep blue oceans meeting the shorelines. It's quite a picture, isn't it? But have you ever really thought about why these features are so incredibly important, how they actually impact our lives and, well, the whole planet?
That's really the key question. We all see these features, yeah. But we don't always stop to think about the dynamic role they play. They aren't just static scenery, not at all. They actively shape our climate, biodiversity, even human history.
Right. So that's our mission for this deep dive. We're going to take a journey through these core Earth features. We've pulled together insights from, the latest research, articles, our notes. And think of it as your shortcut to really getting a handle on Earth's dynamic side. Maybe uncover some surprising connections along the way. Okay, let's get into it. So much of what we see, these mountains, oceans, it all comes down to something fundamental. The constant slow dance of Earth's tectonic plates. It's so important to remember these landscapes aren't fixed. They're always changing, being shaped by these, well, immense forces.
And these tectonic plates, they're the main architects, right? The Earth's crust isn't solid, it's like a big jigsaw puzzle. What's really striking about how these massive pieces move?
It's the combination of their huge scale and just how slowly they move. It's almost undetectable year to year. These plates, the crust basically, they float on the mantle below, which is sort of liquid, viscous, and deep inside, convection currents are churning like a very, very slow boil. That's what pushes the plates maybe a few inches a year. It's this super slow movement that builds up, well, pretty much everything we see geologically.
So when these plates actually meet, that's where the real action is, especially for building mountains. How do you get something as massive as the Himalayas from that?
Well, when two continental plates crash into each other, neither one is really dense enough to dive under the other. So instead, they crumple, they fold upwards, pushing rock higher and higher over millions of years.
Yeah.
That's the Himalayas, the Indian plate hitting the Eurasian plate. Still happening today, by the way. The Alps are another example. But then there's a different situation, oceanic continental subduction.
Okay, what's that?
That's where a denser oceanic plate meets a lighter continental plate. The oceanic one sinks or subducts, and that process often melts rock, leading to volcanoes and volcanic mountain ranges. Think the Andes, the Nazca Plate diving under South America. And you can often tell the age by looking at them. Younger mountains, like the Rockies or Himalayas, they're sharper, more angular. Older ranges, maybe the Appalachians or the Urals in Russia, they're more rounded. They've just been worn down by weather for much longer.
And all that pressure at the boundaries, the friction that leads to earthquakes, right? The earth sort of jolting.
Exactly. Earthquakes are mostly that sudden release of energy that's built up along these plate boundaries. As the plates try to move, collide, pull apart, slide past each other, stress builds up. Eventually, something slips, releasing energy as seismic waves. That's the shaking we feel. The epicenter, the point right above the rupture.
Yeah.
That's usually where the worst damage happens. And while plates are the main cause, yeah, big volcanic eruptions or even collapses in underground caves can sometimes trigger quakes too, but that's less common.
What about volcanoes themselves? How do they fit into this whole picture of moving plates?
Volcanoes are basically openings, vents, where molten rock magma pushes its way up from the mantle to the surface. They often form along those same plate boundaries. Where plates collide and one subducts, you get chains like the Ring of Fire around the Pacific, or where plates are pulling apart, magma can rise up to fill the gap. Think the Mid-Atlantic Ridge deep in the ocean, or the Red Sea Rift.
Okay, so we have these massive forces building things up, but then nature starts working the other way, right? Sculpting things down with erosion and weathering. It's kind of amazing how the planet builds something and immediately starts, well, refining it.
It is quite poetic, yeah. Tectonic forces build the massive structures, but then weathering, breaking rock down, and erosion, moving those bits away with wind, water, ice, they constantly reshape everything. Rivers, for example, they seem gentle sometimes, but over time they are incredibly powerful sculptors. They cut through solid rock, carving out those classic V-shaped valleys, even incredibly deep canyons.
Like the Grand Canyon, that's just mind-blowing. The power of that river over millions of years and the amount of stuff they move.
Oh, absolutely. Take the Mississippi River. Estimates suggest it carries something like 500 million tons of sediment down to the Gulf each year. I mean, try to picture that. It's a staggering amount of material constantly being moved around. That's how landscapes get reshaped.
And then you have glaciers, these huge rivers of ice. They sculpt things differently, don't they?
Very differently. Glaciers are these massive sheets or flows of ice moving slowly downhill because of gravity. Their sheer weight and the rocks frozen into their base just grind away at the land underneath. They carve out wide, U-shaped valleys, much broader and steeper sided than river valleys. And when those glacial valleys reach the coast and get flooded by the sea, that's how you get fjords, those deep, narrow, steep inlets you see in places like Norway or Alaska.
So plateaus fit into this too, those big, flat, high areas, formed and then shaped.
Exactly. Plateaus can be pushed up by those same tectonic collisions, lifting large areas of crust without necessarily folding them like mountains. The Tibetan Plateau is a prime example, formed by that same India-Eurasia collision. But once they're up there, these flat highlands get worked on by wind and water erosion too. Over time, they can be cut into smaller, isolated flat-top features like mesas and buttes. You see a lot of those in drier regions.
It really is incredible how these huge geological processes then set the stage for life itself. Let's shift focus a bit to that. Mountains, for instance. They're not just scenery, they're crucial for climate and unique life forms.
Absolutely critical. Mountains are huge physical barriers. They block wind, they force air to rise, cool, and drop moisture. This creates really diverse weather patterns. The classic example is the rain shadow effect. Like in Nevada, it's dry because the Sierra Nevada mountains to the west catch all the moisture coming off the Pacific. So mountains literally dictate where rain falls and, very importantly, where rivers start.
And they're hotspots for biodiversity too, like little isolated islands of evolution.
That's a great way to put it. Their varied elevations create lots of different microclimates in a small area. This isolation and environmental pressure drives evolution, leading to unique plants and animals found nowhere else. They are genuine biodiversity hotspots, and increasingly important, actually, as refuges for species adapting to climate change.
Okay, let's move down from the mountains to the rivers. Earth's lifelines, really. What's the deeper insight there, beyond just, providing water?
Well, the fresh water itself is obviously fundamental for drinking, farming, industry, supporting all sorts of life. But rivers also provide what we call ecosystem services. They help filter water naturally, transport nutrients, and their role in shaping the land, as we discussed, is immense, both carving it out and building it up.
Right, the carving, we talked about valleys, canyons, but also building land.
Yeah, exactly. All that sediment they carry. When the river slows down, especially as it reaches the sea, it drops that sediment. That builds up fertile deltas, like the Nile Delta or the Mississippi Delta, huge areas of rich farmland, and also alluvial plains along their banks. These flat, fertile areas have been magnets for human settlement and agriculture for millennia. They're why so many early civilizations thrived along rivers.
Which leads us nicely to plains, the world's breadbaskets, they're often called. But it's more than just farming, isn't it?
Oh, definitely. Yes, they're incredibly productive agricultural lands, flat, fertile soil, easy to cultivate. Most of our food comes from plains. But think about it. Their flatness also makes them ideal for building cities, roads, railways. So historically, they've been the preferred places for large populations to settle and for trade networks to develop. Major population centers are often on plains.
And some plains have pretty interesting backstories, like the Great Plains in the U.S.
Yeah, that's fascinating. Large parts of the Great Plains were actually once the floor of an ancient shallow sea in the western interior seaway around 100 million years ago. When the sea levels dropped and the waters receded, this incredibly flat seabed was exposed. Over time, it developed the soils that make it so fertile today. So it's an ancient ocean floor, basically.
Okay, so we've looked at how landforms are made, shaped, and how they support life directly. Let's zoom out now to the really big picture, the planet's global regulators. And you can't get much bigger or more important than the oceans.
No, the oceans are fundamental. They're Earth's thermostat, really. They absorb a massive amount of the sun's heat, especially near the equator, and then ocean currents, like the Gulf Stream, distribute that heat around the globe. That's why Western Europe is much milder than, say, parts of Canada at the same latitude. Oceans also absorb a huge amount of CO2 from the atmosphere, which helps regulate climate, although that's causing ocean acidification, which is another issue.
And of course, they're just teeming with life.
Unbelievably so. From microscopic plankton, which actually produce a lot of the oxygen we breathe, up to the largest whales, they are vast, complex ecosystems. And features within them, like coral reefs, are incredibly important. They're like the cities of the sea, providing habitat and nurseries for thousands upon thousands of species.
Okay, next up, coastlines. We think of beaches, maybe ports, but what's their deeper role?
Well, economically, they're huge. Ports for global trade, tourism, which is massive in many areas, fishing industries. They support millions of jobs and economies worldwide. But ecologically and for protection, they're vital too. They act as natural buffers. Features like beaches, sand dunes, mangrove forests, wetlands, they absorb energy from stormwaves and surges. They protect inland areas from flooding and erosion. They're our natural first line of defense.
Yeah. And finally, something we can't see at all, but maybe protects us more than anything else. Earth's magnetic field.
Ah, the invisible shield. Yes, it's absolutely crucial. Earth generates a magnetic field, creating this region around us called the magnetosphere. And this field deflects the majority of harmful charged particles constantly streaming from the sun, the solar wind, and also cosmic rays from deep space.
What would happen without it? Wouldn't be good, I gather.
It would be drastically different. It's believed the magnetic field prevents the solar wind from stripping away our atmosphere over time. That's possibly what happened to Mars, which lost its global magnetic field billions of years ago and now has a very thin atmosphere. Our field also helps protect the ozone layer, which blocks harmful UV radiation. Many scientists think having this stable magnetic shield was essential for complex life to even evolve on Earth's surface. It provided a safe environment.
So pulling all these threads together, this deep dive really shows how everything is connected, doesn't it? It's not just a collection of separate features.
Not at all. It's one dynamic, interconnected system. You have the geosphere, land, hydrosphere, water, atmosphere, air, biosphere, life, and they're all constantly interacting. Land shapes water flow and weather. Weather erodes land. Life influences the atmosphere and the land and is shaped by them. It's a constant conversation.
And understanding that interconnectedness is why this knowledge really matters for you, the listener, right? Especially now with the environmental challenges we face.
Absolutely. Understanding how these Earth systems work is the foundation for tackling huge issues like climate change, biodiversity loss, pollution.
Yeah.
Take climate change. Yes, Earth's climate has always changed, but the speed of warming we're seeing now is unprecedented in human history and is primarily driven by our greenhouse gas emissions.
And the impacts are everywhere, affecting all these systems we've talked about.
Exactly. We see ice sheets melting rapidly, contributing to sea level rise that threatens coasts. We see changes in weather patterns, more extreme heat, droughts in some places, heavier rainfall, and floods in others, powerful storms potentially getting stronger. And all this disrupts ecosystems. Habitats change. Species struggle to adapt or move, leading to biodiversity loss. It's all linked.
So if we really grasp how these systems work, how does that help us find solutions? How does it lead to, say, sustainable development?
Because this knowledge informs everything. It helps us predict risks, like floods or landslides. It helps us manage resources like water or forests sustainably. It allows us to develop effective policies, whether it's for reducing emissions, protecting natural areas, or adapting to the changes already happening. Sustainable development is all about finding that balance, meeting our needs now, without wrecking the planet for future generations. Understanding Earth systems is key to finding that path.
It makes me think of that bathtub analogy used sometimes here.
Yeah, that's a good one. Think of Earth's resources or its capacity to absorb waste, like the water level in a bathtub. Sustainability means you're only taking water out using resources at the same rate the tap is putting water back in, natural replenishment. Right now, for many things, we're draining the tub much faster than it's refilling. Overfishing, deforestation, pumping CO2 into the atmosphere. It's about systems thinking, understanding those inputs and outputs to maintain a healthy balance for the environment, the economy, and society.
What an amazing tour of our dynamic planet. From those towering mountains shaping weather and harboring life, the rivers carving landscapes and feeding civilizations, the vast oceans driving climate, the coasts protecting us, and that invisible magnetic field shielding us all. Every single feature playing a critical, interconnected role.
It really underscores the complexity, but also the resilience of Earth's systems.
So here's something to think about. Knowing just how deeply interconnected everything is, from the deepest trench to the highest peak, the magnetic field to the air we breathe, what responsibility do you feel? A responsibility to understand these systems and maybe to care for them, not just for us right now, but for everyone who comes after us.